Yeah, we're live. So Git is a distributed version control system, which probably doesn't mean anything to you, but it is. Git is open source. It's very light. It's very fast. It tops most of the other version control systems we have today. Most of them are actually paid corporal versions. And what's really special about Git is that it's, first of all, everything is local on your system. You can work completely offline with Git, and you won't have any problems. You won't have problems working offline and then merging it back to another server or your work or your colleagues or whatever when you need it. Here I have a screen which I've prepared, and you can see we have a text editor in one end and a terminal in another. This is, I'm assuming here that we're talking Linux. If you aren't familiar with the terminal concepts or Linux in general and you're using Windows, then there's Git Bash that you can download from the Git website. Just Google Git, and it does pretty much the same, except that it works on Windows. To install Git, we will use, at least I'm using Ubuntu, so apt-get install. Mine is already installed, so it'll tell me you don't need it. But that's the only command you do, and you're done. We'll cd into our project. Now, this is an empty directory. There are no files in it, and we haven't started working. On many cases, you'd go and clone a repo from GitHub or whatever, but we'll just start from the basic here. Maybe we'll get to networking later. To start a Git repo, all you need to do is to type git init. There, it's done. What's really good about Git is that everything is done in several milliseconds. Now, if we try to look at the directories in the folder, we'll see that we've added a .git directory inside our project directory. We'll look what's in it soon enough. Now, the most basic workflow of Git is the modify, add, commit workflow. Basically, we take a file, let's just say hello world in it. We'll save it as readme.txt, and now our example has a readme.txt file. Now if you look, we have a command called git status. Git status gives us what we have in our directory, what kind of things we have, what files were changed in the directory. So to add a file, all we need to do is type git add me.txt. And then, now that it's added, if we type git status, we see that now the changes to be committed are that we have a new file, readme.txt. After we do that, we can type git commit, enter a commit message, And now we can see that we have a new commit on our branch, added README file. If we type git log, we can see all the commits that were recently made. So we can see two commits here. The added README file with all caps, which is a commit I made beforehand, and the added README file, which we have now. Now you can notice several things here. You can notice that each commit has a long hash notion. That basically means it's a hash of the commit, of the changes made, and the parent commit. That means that you can't simply take a commit object and move it around and expect it to still work. You can't change history like that. That's what it's called. There are commands to do it, but you can't mess with the integrity of the history so easily. A second thing we can see is the author. The author is me, and you can see that it has my name and my email address. That's something you define with Git. You define it with git config, and it basically asks you, the first time you commit, it'll ask you for your name and your email, and you'll have to fill that in before you can commit. Date of the commit and what changed in the commit. Now that we have two commits, we can see that yeah, I lost my train of thought for a moment there. Yeah, we have two commits. We can roll back to any commit we want. If we, let's say in the, I don't want this new readme.txt file. I want to see the state the repository was in before I added this file. Because let's say this file introduced a bug or introduced an error, and I don't want it. I can type git revert. There are two ways. There's git reset. Git revert will add a new commit that reverts the commit I wanted to revert. So if I type git revert and then I add the hash of the commit I want to revert, then it'll prompt me again for a commit message. Let's just use that. And now if we type, see three commits. One that reverts it, one that we added, and the other one which was which existed prior. If we if we list the files in the directory, we see that again we have no files because we reverted the the commit that we've added. The other option is git reset. Git reset will simply move the state the working directory is in based on the commit. So let me just copy that again, and we'll type git reset. Now that didn't work quite as well as I hoped. Yeah, and now we can see that the file was re-added. Any questions so far? None?
I've done part of the thing you sent, so most of these things I've gone through the was it the lessons
All
on the
right.
website, but I don't know about was it Evil Engine? Was he he's
I'm actually not sure. Do you guys have any questions? Leo or Evil Engine?
Clear so far, no questions.
Okay. So we were able to make a commit and revert it if we had wanted to. Now you may have noticed that when we reverted the file, several things happened. It told us that head is now at C592E4A, added readme file. What does that mean? It can get quite a handful to remember these very long hash messages. It's actually it's pretty impossible to actually remember it. So you may notice that um, it only gave us the first seven characters of that hash. If we look at the complete hash, we can see that it starts with the same characters. That's because Git is smart enough to know um, to resolve the complete hash from the first few letters because it's still unique enough. So for example, if I want to go to a certain commit and work on it or branch from it or whatever do, I can just type git, and now I need to give it an address. What's an address? An address can be several things. It can be a hash. It can be a partial hash. It could be a branch name, or it could be relative to the current position, which is head. So for example, I can check out 3A2. Let's see if it gets it. No, error path spec 3A2 did not match any files known to Git. So let's try to add more of the digits, or the characters for that matter. And now Git gave us Git head is now at whatever revert added readme files. Now it gave me a warning that you are in detached head state. You can look around, make experimental changes, and commit them, and you can discard the commits, blah blah blah. The implications of being in detached head mode is that you can't retain the work that you make. Because when you make commits, they aren't tied to anything. Yeah, it's a detached head is when the head is pointing at a certain commit instead of a branch. So you can't save your work. You can commit, but it won't appear in the tree, in the commit tree. If you do want, you need to create a new branch. We're using git checkout my -b new branch name, which we will get to eventually. What is this head? Well, head basically means what commit or what address am I currently looking on. If I go into the Git directory, I can see many things here. One of these is the head file. If I see what's in this head file, you can see that the only thing I have is one line which points at the current commit I'm looking at. If we now get back into our directory and check out back to master, which is the default branch that Git gives us, you tell me, warning, you are leaving one commit behind, not connected to any of your branches. If you want to keep them, this may be a good time to do it. Git branch, new branch name, and into the commit. We don't need that because we haven't made any changes. So now if we get back into the Git directory, and again look, now it points to refs heads master. If we look at the files we have in this directory, you can see the refs directory. So if you go into the refs heads directory, we can see that we have two files here, each for each branch. I have one branch which I have called branch, and one branch called master, which is the default that Git gives us. If we cat, like cat in Linux, for those of you who don't know, cat will simply output anything that's in the file. If we cat the master file, we can see that there is a hash there. And this hash happens to be the very first commit that we've had. Because up until now, we've been working either in a different branch or in the detached head mode. So how do we get around? Let's how do we get around in our tree? We have git log, right? Git log shows us the state of the current branch. We are now in the master branch, which only has one commit. If we move to and we git log, we can see all the other commits that we've made. You can just make it look better. So now you can see that our branch is looking at this commit, and our master branch is looking at that commit. Our head is currently pointed at this commit, the latest one that we have. We move around, we look at certain commits with the checkout command, git checkout. And like I said, all you need to do is give it an address. An address can be either a commit or a branch or a tag, but tag is later on. Right now, head is pointing at the branch. Not a good name now that I'm thinking about it. But it basically tells us that the top of the branch is the one I'm looking at right now, is the one I'm working on right now. Let's talk about branching a little. Branches in most version control system are simply copies of the entire repo. That's generally a bad thing, because if I want to make a branch of a giant repo with a lot of code in it, I want to branch from PHP, the PHP repo, or the Linux kernel repo. Those are huge repos, and if I branch, and that would duplicate the entire code I have over and over again, that's a major waste of space and it's very, very slow. The thing about Git is that it's very fast. In SVN, for example, if I were to do anything that I've done, all of this would have taken me at least 30 minutes to complete all of this. Anything that takes in Git about a tenth of a second takes 10 seconds for SVN to do. It's incredible. Now, as you may have noticed so far, I haven't touched a server yet. Everything is done locally. In SVN, you must have a central server which serves you the code. In Git, that's also a common workflow, but it's not absolutely mandatory. I don't happen to know Preforce. No, I don't know Preforce. At work, we do SVN, and yeah, we do SVN, and it sucks pretty bad. So let's talk about branches a little. In Git, branches are nothing more than pointers at certain commits. If you go back to the under the refs, that we have one file for each branch. If we look at the branch file, we can see that it's pointing at this commit. And if we look at, we can see that it points at this commit. We currently have a branch, two branches that point at two different commits, and yet these commits are not duplicated. They are the same commits. This points to this backwards, but they aren't duplicated in the branches. This makes Git very, very light. It gives the illusion of a tree of branches, while many branches can actually be on earlier points or later points of other branches without actually duplicating anything. To create a branch, all we need to do is to git -b new branch name, because it's awesome. So now we switch to a new branch which is called awesome, and we can again cd into the git heads, and we'll see we have a new file here called awesome, which incidentally points to the same commit as the one we were before we checked out. When we checked out, we were on the branch, and now we're on awesome. So they currently point at the same branch. So now we go back and we do some work on awesome. Work. Now, if we type git state, we'll see that we've modified the readme.txt file. Now we can type again git add readme.txt, but a shortcut, if we want to commit all of the files that we've changed or added or deleted or renamed, we can type git commit -a, and that will add all the files automatically for us. And now again, add awesome to the readme, save and exit. And now, if we type git log again, we can see that we have this new commit. And if we git check to our branch, now that work that we've made is gone, because now our working directory points at this older commit before we've made this change. And now it's back after we checked out awesome again. Now, one of the most amazing things that Git has is with its conflict resolving. If I and you work on the same file, as long as we don't work on the same actual lines, we won't have any conflict at all. Git will know how to manage it. So, for example, we'll in the awesome branch add some work to what we've done. And now if we check out and do some work here, as long as we didn't do it on the same line, there wouldn't be any conflicts. Now, of course, I'm writing total nonsense in my commit messages. Yes, right now we are on branch. Right? You can type git branch, and it'll show us the branches, and it'll show us which branch we're on right now. And now that we've done work on branch, we can now we have a divergence, right? Because this add readme file is the common parent of this is work and this is awesome commit we have on the commit on the awesome branch. See that this added readme file is the same commit. We can see that it has the same hash as the one here. Right? So same hash. But each of these branches has each of these branches has work done on top of those parent branches. So now what do we do if we want to merge? A common problem that we face is that we have this master branch, and this master branch is where we compile our code, or where we deploy to a web server or whatever. It's our main branch. It's our canonical branch. And now we want to develop a feature or fix a bug. So we don't want to do the work on the master branch, because that would mean that all our lame failed attempts would show instantly on the master branch, and if someone tries to build our master branch, then they'll get the incomplete fixes. So what we usually do is make branches. We make a branch for the bug fix, or we make a branch for that feature. We work on it, and then when it's done, we merge it back. We can branch out and merge back. So when we merge, right, because the bug was detected on Monday, but now it's Friday, and I've done my work, but the master branch advanced. It continued. So now I want to merge my work back into the branch. So I'll just check out branch, and now I want to merge awesome into my branch. I want to merge the work I've done on the awesome branch onto my normal branch. So I'll type git merge awesome, and you see that we do have a conflict. We do have a conflict probably because the file isn't big enough. The lines were too close to each other. So now if we come back, we can see that we have this weird thing going on. See, this is head. This entire thing under above the dotted line, the dashed line, is what we have in our current head, in our current position. And under the line is what we have on awesome, is what we have on the branch we're trying to commit. We're trying to merge, sorry. So to end the conflict, we need to remove these. And we'd like this change to happen, but we also want this change, so we can remove this. Right? Now that we've resolved the conflict, we can save. And now, after we fix the conflict, we can commit the results. So git commit. Right, git readme. And you see that it auto-populated the commit message with some things, merge brand awesome into branch, and the conflicts were readme.txt. Now I can say fix that annoying, and now I can commit it. That we've merged that commit, that branch, sorry. If we go again into the Git folder, sorry, we can see that there's this objects directory in it. You can cd into it, and now we see all sorts of directories in it. Git will it'll group the different commits based on their hashes. So you see this hash more awesome has this hash, then it will be in the directory that starts with 5.4 because it starts with 5.4. Let's check out this. Let's see this object. We'll cd into 5.4 and see that there is this one file in here. This file, if I cat it, no, my bad, sorry. Yeah, well, I forgot where it is. There's a directory where it keeps all of these objects and where it points to. Because each commit points to an earlier commit, to a parent commit. And once you can see that, you'll notice that each commit has a single parent. And if we looked at this merge commit, we'd see that it has two parents, the one from branch and the one from awesome. GitHub visualizes this with an actual tree. If you look at how you can, I think it's in the network tab on GitHub, and you can actually see how the commits were made and what merges into what. So now we can commit work, we can branch out, and we can merge back in. Any questions so far? Come on, don't be shy. I'm not that good. All right. Apparently I am. Yay me.
Well, it is quite clear, and well, at least to me, since I've already worked with other file version control systems, it all makes sense. So at
Mhm.
least for me, it's clear because I can relate. I don't know about the others, but I guess they're also following it quite well. So
Alrighty. I didn't understand the question, Leor.
Explain again. How did you track again the parents branch?
What do you mean track the parent
How,
branch?
how did you find the parents branch by the last commit of the last commit?
Um, well, the branch, you can see the branch when you type git branch. Git branch, you can see that you are currently on the branch. Um, and the work from awesome was merged into branch. Now you can see that awesome wasn't deleted when it merged back. I can still go to awesome and continue working on it even though it merged back into branch, and it'll be a different branch all the same. Let me see one thing. All right. Um, Basically, I think there is a command that allows you to see it in a more tree-like thing. Right. I can type git dash dash graph, and now you can see it's a bit more pretty. You can say that. You can see that around here, after this added README file, we've uh, we've diverged into two branches. Right, so the added README file is a common parent to both of these commits. And this commit, this is work, is done on one branch, and this commit is done on another. And then, eventually, we merge those back into the same branch, back into the branch. God, I should have picked a different name. So basically, you can see that you can see our branch here, and I can go back and check out, sorry, Git, and I'm back on awesome, right? So now I can add new. This I simply commit it, and now if I type git graph, git log graph, you can see only the graph of this branch, right? So you can't see this nice long branch thingy that we've done unless we merge it again back in. So if you check out back into again git check, we switch back into branch, and now we want to merge it, merge. Awesome. Now you can see we have conflicts again. So this is what you have on head, and this is what we have on awesome. So we want to add this work on awesome, so we can just delete the rest of it. Right? You see now that this is out of the conflict. The only conflict is here. And since we have added this work, all we need to do is remove these pointers. Save and commit. Now if we type git log, now we can see that this branch continued after we merged back. It continued with some more and then branched back again. Right? Yeah. We can do even better by adding abrev commit. And now it should be shorter. I'm not seeing it shorter. Right? Hold on, maybe I screwed up. No, I didn't. Well, there's this command that someone posted on the internet that allows you to see it a little more nicely. Right? So now you can see in this a little nicer command that you can see it. I'll post it here. You can see it that the master branch is still way back behind. The awesome branch is here, and the branch is here at the top, and the head points to it, because that's where we are right now. So does that answer your question, Lior? All right. Now remember that branches are they're simply pointers to a certain commit. I can take any branch I want and point it and throw it away onto some distant commit and say, this is the awesome branch now, and this is where it points. That work can be done. It's usually not recommended to do it because that involves rewriting history. There's a concept in Git called rewriting history, which is usually frowned upon. It basically means to change the order of the commits or to change the order of the branches. Well, you can do that very well if it's your local project, your own project. But if you're working in a group, this kind of approach will lead to problems because your history is now different than your colleagues. And when you try to work together on the same repo, you'll get problems when you push or when you pull or when you do things that are mainly related to remote repositories. Now, one of the best things about Git is that it's distributed. Distributed is a nice word, distributed. But what does it mean? Distributed basically means that you can, but you don't have to have a central repository, some sort of main stash where the code is kept and it's the most important repository, and if it dies then everyone in the company can just jump out of the window and kill themselves. In Git, every repo has the same weight. Yeah, if they don't back it up. Every repo has the same weight. So if I am called main, or if I am called GitHub, then my repo holds no more meaning, technically, no more meaning than your repo locally. If my repo dies, you still have all the code. And if I decide to stop using GitHub and go and use Bitbucket or some other service or set up my own server, I can still do it. Yeah. So what distributed means is that all four of us can work on the same company, for example, and we can work um, together, and we can push and pull changes from each other as long as we have each other's public keys, and we can push and pull changes from each other, and we don't have to go through some sort of main server. None of our repos is more important than anyone else's. Sometimes it makes sense to have a central repo. For example, if I want to share my code with all of you, it may make more sense for me to upload my code into GitHub and have you guys fetch the code or pull it from GitHub to your own PCs. That makes the code public. On most cases, GitHub has private repos, but on most cases it makes the code public, it makes the code open. And that's the meaning of open source. So the meaning of distributed is that I can, but I don't have to go through that central server. I can work with someone else when it's just me and him, as long as we have, as long as we can both, as long as we have internet access and we know each other's public keys, we can push and pull changes from each other and work on the same repo, even though we're on different computers. In SVN, for example, when you commit, it automatically commits to a SVN server. You can't commit locally. There's just no such concept. When you commit to a server. If that server is busy, then you can't commit. Or if that server is down, you can't commit. You can't work. That sucks. With Git, if the stash server dies for whatever reason, you can still work. Sure, you won't be able to share your work yet, but you can still work. And when the server goes back on, you can push all of your commits right back up. And that's the power of Git over SVN or whatever. Again, I don't know pre-force, but yeah. So the basic thing, yeah, all right. I know that there is one other distributed version control system, but I think that it's paid, and I think that it sucks pretty bad too. Currently, the Git is simply the best version control system that we have. There's simply no other competition that even comes near it today. So yeah, so we've seen how to commit and yeah. So we've seen how to commit our work. We've seen how to revert it. We've seen how to branch out, and we've seen how to merge back in. All of these are basic concepts in Git, and it's already it's already very powerful system to use. For example, I sometimes use Git to back up my game saves in some games. I just make a Git repository of the game's directory, and I play. And when I finish playing, I just commit, and then I can just roll back if I want to. I can roll back to whatever, and I can branch out my saves and play on different profiles or whatever, and explore different aspects of the game. Yeah, it's a valid use case. Git isn't just for code. I want to see you do that with Preforce. No, Git is local. So basically, any user on the system is able to use Git locally. The Linux kernel, which is probably the most active um, repository, it gets like somewhere between 5 and 10 commits per day. It has countless of users and contributors from around the world that that contribute code to it. So no, there's literally no limit to the number of users that can use the same repo. But that pretty much applies to any version control system because the point is to allow for collaboration. The thing with Git is that it makes it incredibly simple and incredibly hassle-free. And you don't need some fat server to sit somewhere and serve you your code. It's my code. It's on my machine. Why would I need a server to host it for me if I don't need to yet? Yeah, so any questions so far on anything local? All right, so I think we will um, end it here for today, and we might continue this on another occasion. These are the basics of Git. On its own, all of these concepts combined make it pretty powerful. We haven't touched Git rebases yet. We haven't touched anything that's remote yet, which adds to the power of Git. But these alone should be enough to tell you why Git is the choice. In our work, even though we use SVN, I use Git locally to track on my changes because each commit in SVN or in Preforce, I'm guessing too, is a big deal. It involves going to the server and it involves very strict rules. You need to reference a ticket in Bugzilla or in Jira or whatever system you have to track bugs or to track tickets. So you need to do this and you need to do that, and you need to sing backwards and stand on your head when you commit. So the small pieces of work that you do, well, but yeah, all right. Sometimes you don't need to actually do stuff. You don't need your commits to be anything special, but you still need for the request to go to the server and for the server to return a response. And sometimes the server is down, so what do you do? Right? So with Git, you can simply commit. Right, wait and pray, exactly. So with Git, you can simply commit, and once you're done, Once you're done with all of your changes, only then you can choose to push to a remote repo. And also, since Git is practically only is file system only, it doesn't do some magic registry, some black magic with the registry, and it doesn't require a server, and it doesn't require anything other than a file system. You can use it with other version control systems. So you can commit in Git, and you can just tell your other version control system to just ignore the Git directory, and that's it. You can work with Git locally, and then when you're done, you can just commit to the server, to the remote server with Preforce or SVN or other whatever other version control system that you have. That's a very powerful concept. It really is, and I'm using it. I'm using it daily, and it's real fun. Any other questions on usage of Git and I don't know, more of the concept of Git, how it works, what it does?
I got a question. What
Yeah.
happens when several developers work on the same method and they obviously turn out different? How do they merge?
Well, when someone would eventually want to merge, they'll get this scary conflict warning that they'll now have to fix. And when they fix it, it'll tell them that they can't commit the merge, because a merge is basically a commit. Right? It's a commit with two parents. And if those two parents conflict, then you can't complete the merge. So what will happen is that the developer that tries to merge will get this scary warning, and it'll tell them, oh look, your readme.txt file has a conflict. Please go and resolve that conflict, like we did twice or three times in our readme.txt file, and it tells you that no, wait, you have a conflict. Now you need to, I don't know, you need to resolve the conflict before you can commit. And then the developer would go to that file and he'll see where the conflict is. And you should trust the developer to be able to solve the conflict without hurting each other's code. Or he can choose to simply ignore the other developer's code and to just merge his own changes in. It's a matter of, who is merging. You can determine that only the team leader has merging rights into master, or has uh, uh, there's the concept of pull requests. Only the team leader can pull from other repos into the master repo, into the central repo. And so the developer will have to resolve the conflict and then commit. And then he'll be able to commit properly. That happens when Git cannot determine whether or not a conflict is when Git can't resolve the conflict itself. Because if you have a large file and you make changes in two different parts of that file, Git won't complain. It'll manage to resolve the conflict on itself. But if Git can't do it, if the changes are too close to each other, if the changes are in the same line or very close to each other, then Git won't be able to do it. And so it'll ask the developer, the guy who merges, it'll ask him, please resolve these conflicts and then come back. And once he comes back, he'll be able to merge. And that happens very often, actually. It's pretty rare that more than two developers work on the exact same method, on the exact same class, on the exact same file. If you do that, you probably have some other issue, like management. But Git can handle these cases, and if it can, it'll just ask you to handle them for it. Any other questions? Once, twice.
Okay, another question. I recently browsed some Git projects like the chatbot, and it has interesting graphs that are visually helpful. Because this SC art in the console, it's cool, but it's not very helpful. Do you think you could show us a better graph next time? Or maybe we could work on a demo project that could show us the basic and often met problems with Git.
Yeah, sure. I mean, this is the command line interface. I prefer to teach the command line interface first because any graphical interface that you may see, any specific Git client, or even editor plugins will rely on that command line interface first. And so knowing it makes you understand any other graphical user interfaces. But yeah, when we touch remotes, GitHub has a very nice visualization of this commit tree that we see here. It's even though it looks fancy, it's pretty crappy. And GitHub does it a little better, from what I can tell. Let me see if I can find a small project that can nicely visualize that. Hold on for just one moment. Right. Can you see it? Yeah, you can. All right. So here you can see this is a repo for room 11. Room 11 is the PHP room on Stack Overflow. And we've made a small little with a small little room packed, like guidelines for the chat. And this is hosted on GitHub. So the source code is available. You can see it here. Right? There's the README file, some HTML files, a favicon, a favorite icon, which is this little elephant thing you might or might not see. I'm not sure of the quality of the video. And when you look at the network tab, you can see all the commits that were made from the beginning of the repo. You can see all the branches here. Bob Waynand branched out, and he removed from here. Kyra fixed some typos, and then merged back in by B. And you can see that Peter killed Bootstrap on some point, and then on the February 14th, I merged the changes that Kyra gave us. And if I click on it, you can see the actual change that she made. Right, so you can see the do's turned into don'ts, and yeah, there's not much other here. See, missing clothing, I'm not actually seeing it, but it's somewhere around here. Yeah, see, so we started M here, and we didn't close it, so she added it. And you can see that um, we've made a lot of changes over time. See, I merged quite a bit actually, and you can see that there are several other people with cloned repos um, that updated and then merged into the main repo back in. So this graph is rather similar to here, only it looks a lot better. And yeah, that's practically how it's made. And there are a lot of GUI interfaces that allow the same kind of view. For example, the IDE I'm using, PHP Storm or IntelliJ IDEA, it also has this sort of graph thingy that you can look at. But yeah, the most important thing, I think at least, is the terminal thingy. Um, so yeah. Any more questions? Leo, you've been awfully quiet. Alright then, folks. Thank you for coming and listening to me rambling and stumbling and getting confused all the way. Yeah, me too, I know. Let's see if we can do it again sometimes, perhaps next week, perhaps this week, I don't know. And yeah, well, we'll see you later, and feel free to ping me on chat or in Hangouts or whatever if you have more questions. The best way, I think, is just start a project and start, committing, play around. If you want to restart, you can simply erase the .git folder and type git init again, and it'll just start completely fresh. New repository, new everything. There's also this other training web application that I think at least Dice knows, right? But I'll post it again on the room if anyone wants it. And there are a few resources. The Git documentation is really good. Yeah, thanks. And the documentation is really good. You can also read that. Yeah, well, I think that's it for tonight. Thanks for coming. Thanks for those who watched. I'm not sure how many watched. And yeah, 3. No, I think 3 participated, but there was others who watched, because I shared the link into the PHP room because someone asked me, so I think they watched. But yeah, thanks for coming, and I'll announce if there'll be a sequel. All right, bye bye, folks.